Hi everyone. So class was canceled today due to weather, but I thought I should do a video where I'm covering all the exercises that I hope to do in class today is preparation for the test, because we are still going to have a test on Monday. So if you have questions about any of this stuff, please go to either the Logic Lab or jump on the discussion board on Quarkus and we'll try to help you out. Okay. So let's do some symbolizations and then some derivations. Okay, so either Yolanda leaves and Veronica doesn't, or Veronica leaves and William doesn't. And we're going to use the symbolization scheme. V for Veronica will leave, W for William, and Y for Yolanda will leave. Okay, so when you're looking to symbolize a sentence, recall that the best strategy, in my opinion, is to start from the biggest parts of the sentence, figure out what the major connective of the sentence is, what's the overall thing it's trying to say, and then deal with the parts. Because trying to understand it all at once can sometimes be overwhelming. So if you start from the biggest parts, then you just make each step smaller and smaller until you're done. So what are the major parts of this sentence? Well, the comma is a really good hint. So the comma tells you something about the structure of the sentence. It tells us that this whole thing is one big part and this whole thing is one big part. And we've got an either or sentence here, so either this or that. It doesn't really change the meaning that we have either in front. That doesn't do anything odd, so you can just kind of ignore that. So Yolanda leaves and Veronica doesn't, or Veronica leaves and William doesn't. So we know that the major connective is an or. We have a something and something. Okay, so now it's just dealing with it by its parts. So Veronica leaves, or sorry, Yolanda leaves and Veronica doesn't. So Y and not V. Okay. And then or this thing, Veronica leaves and William doesn't. V and not W. Okay, just something to note. These brackets do actually make a difference. So it's not just helping me to read it. If I'd written the following, it wouldn't have been a well-formed sentence. So if I said Y and not V, or V and not W. This is not a well-formed sentence. We've got ands and ors mixed up together, so this just doesn't make any sense in our logical system. So you really do need the brackets here to disambiguate what the parts of this sentence are in order to properly capture the logical form of the sentence. So do include brackets when you think it helps clarify what's going on. Okay, another example. Only if Todd gets enough sleep will he be not both cranky and sad. Okay, so what's the major connective of this sentence? Well, I think it's only if something, then something. And it's fairly clear that Todd gets enough sleep and he's being both not cranky and sad are the main parts of this sentence. So recall our rule. So only if is a conditional, but recall our rule about only if. Whatever comes directly after only if is the consequent. It's just the opposite of if. Whatever comes after if is the antecedent, if x then y. Whatever comes after only if is the consequent. So Todd gets enough sleep, R is the consequent. And then something something is the antecedent. So try to recall why this makes sense. Only if this thing happens will this thing happen. Well, that means that if he's not both cranky and sad, then it must be the case that he got enough sleep. Only under the condition that, or only if, says if it's the case that he got enough sleep, it must have been the case that this thing happened. So, this thing is a guarantee that he did in fact get enough sleep. Okay, so not both cranky and sad. Not both cranky and sad. So this is symbolized as it's not the case that he is cranky and sad. Okay, so here's another way you could have said that. Another perfectly good symbolization of this is not P or not Q. Therefore R. And now that you know De Morgan's law, you know that these are two logically equivalent ways of saying the same thing. So these are both perfectly good symbolizations. These are both be exactly as good on the test. Here's something that's not the same. Here's a different symbolization. It means something different. It doesn't capture the meaning of not both. So if I'd written the following, if I'd written not P and not Q, then R, that's a different sentence. That says, if it's the case that he isn't sad and isn't cranky, then he got enough sleep. But that's not the same as not both. So not both says it's not the case that both of them are true. Not that this one is true, not true, and this one is not true. If I wanted to say this thing, so this thing is equivalent to only if R neither P nor Q. So this says neither nor P, if neither nor P then Q, then R, or only if R neither P nor Q. So neither nor is not the same as not both, and make sure you get them right. So these both say not both, right? So it's not the case that P and Q are both true, which is logically equivalent to not P or not Q. But this is something different. Don't write this. If you get neither nor, then write this. But if you get not both, do one of these things. Okay. Right. Despite Jay liking parties, drinking wine or beer is a necessary condition for him to go to one. All right. So we're just going to remember our stylistic variants. So what does despite say? If I say despite X, Y, that's just saying the same thing as X and Y, right? So I know that this has a different tone, it has a different feeling to it, but we're really not doing tone in this class. Despite X, comma, Y is just to say that X is true and Y is also true. So this is an and statement, something and something. Okay, so despite J liking parties, comma, again the comma is the hint on where the break is, despite J liking parties, so W, I guess we didn't need these brackets here, but W and something. Drinking wine or beer is a necessary condition for him to go to one, that is to go to a party. Okay, so necessary conditions. Let's recall what a necessary condition means. Right. So if I say oxygen is necessary for fire, that's true, right? If you need oxygen for there to be fire. But that's just the opposite of saying, or it's a completely different thing to say that oxygen is sufficient for fire. We're very lucky that that's true because there's oxygen all around us and we're not constantly on fire. Nonetheless, any time that there is fire, there must be oxygen. So that means that we want to symbolize this as if there's fire, then there's oxygen. So the presence of fire is a guarantee of the presence of oxygen. It's not the opposite thing. It's not that the presence of oxygen is a guarantee for the presence of fire. So that's not what a necessary condition is. That's a sufficient condition. Okay. So fire, then oxygen, which is to say oxygen is a necessary condition for fire. So if drinking wine or beer is a necessary condition, then it goes in the consequent. So we're gonna have to have a conditional here, and the consequent is beer or wine. So Y or Z. And then the antecedent is going to a party. X. Okay? So if this said drinking wine or beer is a sufficient condition, then this would be flipped around. If it said it's a necessary and sufficient condition, then it would be a biconditional. But because drinking wine or beer is a necessary condition for him to go to a party, that means that wine or beer goes in the consequent. So if it's the case that he went to a party, it must be the case that he was drinking wine or beer, not the other way around. Okay. All right. Either there is no election or the Conservatives will win if and only if both the Liberals and the NDP fail to win. Okay, so where do we start parsing this thing into its parts? Once again, the comma is your clue. So the comma tells us that there's a major break in the sentence, that it indicates that that's a carving off one big chunk from another big chunk. So either there's no election or the Conservatives or blah, 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 this thing. So either or, once again, either doesn't do much for us. So there is no election or this thing. Okay, so we know there's an or here, and we know one half of it is no election. T is there is election, so not T or the rest of it. Okay, so now we're going to ignore this and just pay attention to the other half. The Conservatives will win if and only if both the Liberals and the NDP fail to win. Okay, so if and only if, that's our biconditional. Okay, so Conservatives will win is one half, and both the Liberals and the NDP fail to win. Both the Liberals and the NDP fail to win. So we want that to be not R and not P. Okay. So, why did I write not R and not P? So could I have written, for example, it's not the case that R and P? Well, no, that doesn't say the same thing as both the Liberals and the NDP fail to win. This says it's not the case that they both win. And of course, they both weren't going to win. Only one party can win. So only both this is not true and this is not true. And that's this thing. Again, De Morgan's tells us that this thing is equivalent. So that would have been an okay way to write this half of the biconditional as well. So this says it's not the case that R or P is true. Neither, and if R is true, then this whole thing is true, and then this is false. Or if P is true, this whole thing is true, and then this is false. So the only way to make this sentence true, not R or P, is for R to be false and P to be false. And again, we see that this is equivalent, so the only way to make this thing true is, of course, R to be false and P to be false. Okay. So I think that's my last, oh no, one last example. All right. So, dancing is fun, but not easy for everyone. And if it is something that everyone should do, then neither Joe nor Remy should stop dancing. Okay. So, here's our comma. Dancing is fun, but not easy for everyone. Let's just start with that. Well, we know this whole thing is going to be an and. Okay, so dancing is fun, but not easy for everyone. Got dancing is fun. What does the but say? Of course, but is equivalent to and. So dancing is fun, and it's not the case that it's easy for everyone. Okay, so that's this thing. P and not Q. And if it is something that everyone should do, then neither Joe nor Remy should stop dancing. Okay, good. So we know this whole thing is going to be a conditional, and we've got dancing is something that everyone should do is R. Again, whatever comes right after if is the antecedent. If this thing, then this thing. Okay, so what's the consequent here? Neither Joe nor Remy should stop dancing. So we got neither nor this time. Recall this one, neither nor. they're both false. So not S and not T. Okay, and there you have it. So once again, De Morgan's tells us that this thing could have been not S or T, with the not being outside of the brackets, and that would have been okay too. So both of those are just fine. Okay, so just to remind you, general strategy tips, remember your stylistic equivalents. So things like and being the same as but, and despite being the same thing as and. Remember the rule about if-thens. Whatever comes right after the whatever comes right after if is the antecedent. Whatever comes right after only if is the consequent. And remember the strategy of starting to deal with these sentences not by trying to figure out everything all at once, but just trying to figure out what the main connective, what the main point of the sentence is, break it up into its largest pieces, and then deal with those pieces one by one. And that commas help you find them. Okay. Okay, so let's do some derivation practice. On the test, there's going to be 4 derivations. 2 of them are going to be basic rules only. 2 of them are going to be derived rules. And I'll remind you that on the test, what you'll get is what I've uploaded as the blank derivation sheets. I've got a list of the abbreviated names of the rules, but not what the rules are. So you're going to have to remember the rules yourself. Okay, so this is going to be, we'll treat this as a basic rules question, and we'll try to derive this using just the basic rules. Right. So, show P or Q, biconditional, not P, then Q. Okay, so when you're trying to show a biconditional, the thing to do is to try to show one half and then show the other. So first I'm going to show P or Q, then, if not P, then Q. And then, so let's call that square then circle, and then I'm going to try to show circle then square, and then I can put them together in a biconditional. Yeah? Okay, so we're working on this one right now. Work on one half. Okay, so now I've got a show line, and it's a conditional. So anytime I've got to show a conditional, I start by assuming the antecedent. So assume for CD, and I'm going to say I'm going to try to show the consequent. If not P, then Q. Okay, and once again, I'm trying to show a conditional, so I can assume the consequent and try to show the, assume the antecedent, try to show the consequent. And I can assume ID on that. If it's really obvious to you how you're going to finish off your subderivation, you don't have to do a bunch of these. So this second show line is not strictly speaking required, but it's usually a good idea. I think it's a good idea if you're not super confident you know how to close off the derivation, which is probably going to be most of the time. I mean, I always feel like that when I start a derivation. Oh, I have no idea I'm going to do this. So these second show lines are good. They're potentially useful, and they can never hurt you. So I strongly recommend that you do these on the test. Okay, so this thing is a theorem. We're trying to show a theorem, meaning I've got no premises to work with. So it's kind of easy to survey what I have available. I've got line 3, line 5, and line 7. All right, well, I've got something I can do here, right? I can show, actually there's a couple things I can do here. This is going to be a fairly short subderivation. So because I've got not P, I can get Q. Because I've not got not Q, I can get P and assume ID somewhere here. So I'm going to say 3, repeat. Do remember to use the repeat rule to bring anything that you need to bring into a subderivation. 3, repeat. 5, modus tollendo ponens. will give me, so 3 and 5. So I've got the negation of this half, which gives me Q. And that's it. I got 7, 8 ID. So I've shown Q. I also could have closed this off as a direct derivation, but that's fine. Okay, now on line 6, we've done a conditional derivation. And on line 4, we did another conditional derivation. All right. Okay, so take a step back. Remember what we were doing. We were showing both halves of this biconditional. So now we've shown this half. Now it's time to write a show line for the other half. Show, if not P, then Q, then P or Q. Okay. So we get to assume, if not P, then Q for conditional derivation. I'm going to try to show P or Q. Now, showing a disjunction is not too terrifically difficult most of the time. We can assume ID here, probably not going to do much for us, but you know, it's worth a shot. Now, basically we just have to show P or show Q. So I'm going to have to write a new show line for one or the other of these things. So I'll just pick one at random. Show P. Okay. And keep in mind, you don't have to write, don't write anything in here. You don't have to write anything in there to do anything. Okay. So show P, that's an assume ID. And now we can use that with our, basically just, we've got 3 available lines here. So we've got 13, 15, and 17. 13, repeat, bring that into my sub derivation. And 17, modus ponens, gives me Q. Okay. All right. Well, now I've shown Q. What can I do with it? I can use this line, line 15, and it's a good thing that I did this assume ID. I can say P or Q, that is line 18, add. So I've just taken Q and added P on. Okay, cool. What do I do now? Well, I can 15, repeat, 19, ID. So 15 is not P or Q, this is P or Q, so this is a contradiction. I've shown P, not by showing P, but by showing a contradiction with something that I have. Okay, so now I've got P. Great. What do I do with P? Well, I just do the exact same move that I just did, because showing this disjunction is just a matter of showing one half of it. If I've got the other half, then I can certainly get P or Q by saying line 16, add. And that is a direct derivation, or directly derived the thing that I was going for. All right. Line 22, I'll say on line 14, I did a conditional derivation. This is the consequent of this thing I was trying to show. So that's done. Now it's just a matter of putting our 2 parts together. So recall where we were. We're here. We've done one half. We did the other. Now it's time to just stick them together and we're done. So line 2 and line 12. So 2, 12, we're going to take some conditionals and turn them into biconditional. So P or Q, biconditional, If not P, then Q. 24, we did a direct derivation. Okay. That was a long one. So this was in fact one of the basic rules questions from last year's test 1. So now you've seen an example from the test from last year. So I'm going to show R or W. Okay, so in basic rules, I would probably approach this by just trying to show R or try to show W and add them together. It's still an option, but I can also do the following. I can also say not R or W and assume that for ID. And in derived rules, this is a very useful line because what I can say is line 2 De Morgan's. And recall the rule for De Morgan's, you just say you apply the negation to both of the parts and flip the sign, which means I now have not R, that is 3 simplify, and I have not W, 3 simplify. Okay. So let's see what I can do with that. I can, let's survey our resources here. What have we got here? We've got 4 and 5 looking like pretty useful lines. Premise 1 is potentially useful, and we can make it more useful for ourselves by doing the following. We can say premise 1 negation of conditional. Now, if it's not the case that if P then Q, there's only one case in which, just to remember this rule, there's only one case in which this conditional is false, and that's when the antecedent is false, or is true. Antecedent is true, and the consequent is false, right? So if it's negated, then you know that this is true. Okay, that's also a pretty nice line to have. Just simplify it apart for ourselves. 6 simplify, not Q. Okay, good. So now we've got a bunch of potentially useful lines. 4, 5, 7, and 8 are all looking pretty useful. Let's see. So this is a big conditional. In order to do something with this, generally speaking, what I want to do is show the antecedent or the negation of the consequent. Just hold off on that for 1 second, see if there's anything else I can do. And indeed there is. So I've got on line 5, I've got the negation of one side of a disjunction, which means I can get the other side. So I say 5 premise 3 MTP, modus tollent opponens, and that gives me not S, then Q. Okay, potentially useful. So what I'm going to do now, so here's another thing I can do, 8, 9, modus tollens, giving me, I'll just give myself S. It would be not S or S because it's the negation of the antecedent. Also, very potentially useful line. Okay, what it would be nice to do now, so now I've used premise 1, got all of its parts. I've used premise 3, I got these parts, and I now sort of like cracked them open and got the bits of that. So I'm really just taking these big complicated things and breaking them down to their parts, so I have a bunch of available lines. And that's the kind of thing that you can do once you have De Morgan's, negation of conditional, these derived rules. You can really just take these big complicated things and, generally speaking, break them down into their parts until they're in these tiny little useful parts. Nonetheless, I'm feeling a bit stuck. I haven't done anything with premise 2 yet. So maybe it's time to do something with premise 2. It would be nice if I had, so therefore I'm going to decide to try to show the antecedent. Show if R then S, and if I can achieve that goal, I can get the consequent. assume the antecedent for conditional derivation. This is one of those rare cases where I'm not going to do the second show line just because I've got not R up here. I've got not R, so I can just say for repeat 12 ID. So even though I started a conditional derivation, the fact that I've got the opposite of something that I've got inside the subderivation is enough to close it off. It's a mixed derivation, but that's fine. Okay, so that was using not R to show if R then S. So I got R, if R then S now, and I can use it. The point of that was to use it with premise 2. So we say line 11, premise 2, modus ponens, giving us not P and S. And again, I can crack that open with De Morgan's. So 14 dm giving us not P or not S. Again, you just take away the negation that ranged over the whole sentence, apply it to both of the parts, and flip whatever this sign is. Okay, so now I've got, I've got 3 things that are very potentially useful here to find a contradiction. I've got P, S, and not P or not S. So I've got several ways that I could finish this thing off. One way of finishing it off, without even doing this De Morgan's thing, what I could do is just say line 7 and line 10 adjoin, and that gives me P and S, which is enough to say on line 14, 16, ID. And notice that this is all within one subderivation, so that's actually the end of this derivation. Okay, a couple more ways I could have finished this off once I get to this point. I could have done the following. I could have said, so line 7, double negate, so this the negated version of this, and then that gives me, so if I do line 15 MTP, that gives me not S, and then I could close it off again by saying 10, 16 ID, and done. And I think you can see you could have done the same thing by using double negating S to get P, or not P, and closing it off with 7. Okay, so things to remember here are just that a bunch of stuff has become useful that didn't look useful before. Negated conditionals, so negated conditionals like this, negated disjunctions like this, negated conjunctions like this. You can also turn disjuncts into a disjunction into a conditional, or a conditional into disjunction with CDJ. So really just practicing a whole bunch of these is the only way to kind of get fluid mastery over these new rules. So I strongly recommend you go through as many questions on Logic 2010 as you can. And again, I recommend you do them by hand if at all possible. Okay, I'll leave it there for now. There'll be some truth table practice posted on Quarkus, so check that out. Review the concepts of validity and the trivial versions of the concepts of validity. Practice, practice, practice. Practice as many of these derivations as symbolizations as you can stand, and sort of get fluid, make sure that you know the rules, that you've memorized the rules, and remember to practice pen and paper, because you won't have Logic 2010 on the test to fill out the outputs for you. You have to do that yourself, and it's tricky to remember the rules if you've only practiced Logic 2010. Okay, got any questions, please get in touch, and we will see you at the test.